Hello everybody, today I'll teach you how to mess with any Calc 2 student you ever come across. Now there are two types of people that are going to be watching this video, those who have taken Calc 2 and those who haven't. So to those who have taken Calc 2, you'll probably understand, or probably have like an easier time messing with the Calc 2 students, whereas those who haven't yet, you could probably figure out a few like sneaky ways you can mess with them, but you'll be out of the loop for the most part. Now, anyway, to start this off, we'll start off by looking at a specific type of integral, okay? Indefinite integrals. Right. So when you learn integral calculus, you'll learn that there are two types of integrals. You'll have indefinite integrals and you have definite integrals. So when it comes to indefinite integrals, you'll have some sort of integral like this. So like the integral of some function of x with respect to x, and then this would be equal to the antiderivative, or big F of x, plus some constant of integration. It's arbitrary just because we don't know what it is. However, it might end up being useful if you need to figure out what line you'll be messing around with. But anyway, key thing to note here is that there are no boundaries. So, in other words, this requires a function as your output. Right, so let me shorten this out and put this down here. Right, so already from this, you could already kind of tell where this is going to be going if you've already taken Calc 2 or if you're like, really into integrals. So let's start off with an indefinite integral, and let's say you have e to the x squared dx. Now this is an indefinite integral, right? No bounds. The key thing here is that when you try to solve this using any of your like normal integration methods like IBP or U substitution, you see quickly that you can't, because you'll end up with some other weird integral that's just harder to solve. I mean, if you know how to solve this, then you know, but at the moment, there are no ways of solving this to just any normal Calc 2 student. Now, if you've already taken Calc 2, chances are that if you're watching this video, that you're one of those go-getters, that you're someone that likes to take on a challenge. So without knowing that this integral is impossible, you probably actually try solving it, and some of you astute folks, you'll probably actually try really hard for hours on end to try solving it. And I've been there, I've tried that too. But it's important to realize that there are some integrals, more specific like this one, that actually have their own functions. And in this case, this one's the error function, or ERF, of x plus c. We call these non-elementary integrals because their functions are non-elementary, like the ERF function. That being said, let me push this one aside. There are quite a few other indefinite non-elementary integrals that you could definitely use to start messing with like your friends in Calc 2. Two of them that come to mind are the indefinite integral of sine x squared dx, and, well, conversely, the cosine of that. So indefinite integral of the cosine of x squared dx. And same issue applies here. You can't do this using parts. You can't use this using U substitution or trig identities or anything really cool like that. Instead, these are non-elementary. I don't remember what these evaluate to, sadly, so we'll brush beside that. But you can still use this to, just mess with your friends. Right. Few other examples that I can think of off the top of my head. You can have the indefinite integral of 1 over log natural x dx. I also don't remember what this one evaluates to, sadly, but again, all you gotta do is ask your friends in Calc 2 to solve this, and I mean, you know, they'll probably try solving it, right? There is actually one I do remember the answer to, I think. So if you remember in Calc 1, one of the first few limits you ever do is sine of x over x dx. And with this, you'll have the SI function as your result. Again, this isn't an elementary function, so as a result of trying to integrate this, you'll end up with your SI function here. And I mean, yeah, that's pretty much it. You can't really integrate this using any of your typical integral methods. I guess another one I still wouldn't know the answer to would be x to the power of x with respect to x, right? Now, these are all fine and dandy, but what about the other type of integrals? What about like definite integrals? So this next section of the video is going to be dedicated to just solely that. And any of you that have definite integrals. Now, any of you that have already, taken Calc 2, you've pretty much mastered it at this point. You'll start seeing, you'll probably start noticing certain problems that arise here. Like, for example, let's say you have this integral, right? So e, and then you already know that e to the x squared dx is impossible, so the indefinite integral of e to the power of negative x squared dx should probably also be impossible. And then if you add the bounds, like say negative infinity to infinity, then whoops, you just automatically, or not automatically, accidentally given yourself the Gaussian integral, which is solvable if you've taken Calc 3 or if your Calc 2 professor is really cool. But sadly, they can solve this, right? Maybe you might accidentally give some sort of bounds, right? Like say 0 to, I don't know, a, and then you give some sort of integral f of x that can be solved using Feynman's trick or Feynman's technique. And, normally it wouldn't be solvable, but with the bounds, you're letting them abuse the fact that they have bounds. Now, this is already kind of a lose-lose situation here, especially considering that even if you give them bounds, if they know how to use series, like let's say, for example, you give them e to the x squared dx from 0 to, I don't know, 1. If they know how to use series, then they'll just use a series expansion for this. So 0 to 1. So you have n is equal to 0 to infinity. And then, the expansion for this should be x squared to the power of n, so x to the power of 2n over n factorial dx, and then you could just integrate this by, doing it term by term, and then you'll have, let's see if I remember. It should still be the series n equals 0 to infinity, and then since it's 2n, you got to add 1 to the exponent. And then one of the things you divide by is n factorial. But then since you're integrating this, you gotta divide by this as well. And as a result, you should have 1, 0 as your bounds, and then, well, yeah, you could easily integrate, or you could easily evaluate this. Assuming I'm thinking about this correctly, but Taylor expansion is a threat to us because we want to make it impossible, right? We want to mess with them. So what we can do instead is do the really, really annoying route of, okay, so you know how in, and this goes out to just everybody, not just anybody that's actually taking Calc 2. You know how early on, like before Calc, maybe in pre-Calc, or if you've taken quantitative reasoning, you'll know that there is a log natural function, right? And then you know that there's a domain. So log natural of x works, but only if x is greater than 0. Well, what you could do is set 0 as one of your bounds to 1, and then you could give them the integral of logarithm x dx. And you know, any Calc 2 student, I mean, so long as they're not like actually as good as somebody that, you know, could see like 5 steps ahead, they'll see this and they'll be like, oh, hey, I know how to integrate this, it's by parts. And then they come up with ln x plus x ln of x plus x, and then on the bounds from 1 to 0. And then they, you know, they evaluate at these bounds, and then for 1 they get 1 because log natural of 1 is 0, plus 1 is going to be 1, and then they try to do the exact same thing with 0, but then they realize they can't actually use the 0 here. So inadvertently, I mean, you pretty much, you know, trick them into trying to solve something that, you know, is obviously wrong. There are probably ways to solve this. Again, it's pretty late at night. I don't remember the methods here. So sadly, I won't be able to help you too much out on that. Maybe a bit later when, you know, it's morning and I actually have more than 5 brain cells to record videos on. Aside from that, anybody in, let's take Algebra 2 for example, could point at this, and then if you'd ask them, you know, what the domain of x is, they'd tell you x can be all numbers. Let's see if I remember set notation. X can be all numbers from negative infinity to 2, not including 2 obviously, union 2 to positive infinity or just infinity. Right, so pretty simple stuff. Anybody in Algebra 2 could do this. So what you could do instead is, you know, make one of the bounds 2, or better yet, if you want to hide it even better, you can make one of the bounds 3, the other bound 1, and eventually you'll reach 2 as one of your bounds, and then you could give them this as the integral they got to work out. Now, again, anybody in Calc 2 would probably see this and say, oh, hey, that's ln of x minus 2, right? Because if you do the u substitution, you'll end up with ln of u if you substitute u for 2 minus x, and then, you know, since you don't have to like change the integrand too much with the derivative, since the derivative of x minus 2 is just 1, you'll end up with this integral, and then you end up with this on the bounds of 3 and 1. Then actually, I think they start seeing the problems here when they see 1 as a bound, and then they have the integral of that, but we can ignore that for now. Right. Now this is definitely one of the things you could definitely like just try messing with them. Right. So I had one other sample topic with definite integrals. Actually, now that I think about it, might work with either case. There are of course some integration techniques that Calc 2 students have yet to learn. Now, if you're dealing with a Calc 2 student that already knows Feynman's technique, chances are they probably know literally every other technique under the sun. But in case they don't, you could always do the simple universal trig substitution, or Weierstrass substitution as some people like to call it, where you have an integral in the form, I think, dx a plus b cosine or sine x. You could probably have something like this, and then, you know, like, I mean, everybody's first reaction is probably by parts or u substitution or trig substitution, you know, stuff like that. But when you actually try that here, it doesn't work. Well, technically speaking, there is a substitution that works, but most Calc 2 students wouldn't know. So assuming they don't know about universal trig substitution, Weierstrass substitution, then you should be fine. And bonus points if you decide to put 0 as one of the bounds. So if you have, let's say, if your a here is 0, and your b here is 1, or literally any constant for b, then if you put 0 here, you should be able to like start messing around with just the fact that it's secant here, like you're taking the integral of secant. So I mean, yeah, if I'll write it out, Weierstrass substitution, as some people like to call it. Better name for it, in my opinion, is universal trig sub. I'll just say sub, but it's universal trig substitution, that they like to call it out in places like Russia. Anyway, so high chance that any Calc 2 student you'll meet, especially here in the States, won't know this. Fair chance they probably won't know about Feynman's technique, or rather, I like to call it derivation under the curve. Sorry, it's almost midnight. Derivation of the curve. They probably won't know how to do this. There's definitely like a whole other list of things they probably won't be able to do. One of my favorite things to do, and I found this off of Brilliant, not sponsored by the way, is giving an integral that's actually easier to do as a multivariable integral rather than just one integral, and going from there. Now, me personally, I've only ever seen this done on Brilliant, so I can't, just out of the blue come up with some sort of integral that's really easy to solve like that, especially not now at this hour, but maybe if I figure something out, I'll make an update video and like post it in the description. But anyway, anything that deals with multiple integrals, so I guess you could probably say like the Gaussian integral might be useful to like trick them. So Gaussian integral, multiple integral, or simpler multiple integral. I don't know what they call it on Brilliant. I mean, outside of that, like, you could just, I don't know, make some sort of weird series question, like tell them to solve it, or I don't know, make them prove something, It's probably unlikely that they could figure out a proof, to be honest. We've all been there. I mean, then again, they could probably be taking discrete math at the same time, and in that case, you're in big trouble, but, or maybe they just really like math. But anyway, that's about it for this video. Thank y'all for watching and sticking this long in the video, and I'll see you next time.